So now we will be seeing about the average particle size of a mixture. So this will be defined in the many ways, but the most common is the volume surface mean diameter, which is related to the surface area AW as this equation. See here, ds bar is equals to 6 divided by 5s into AW into rho P. So we have the value of AW here as I have discussed previously. So just we are substituting it in this equation, AW value, okay, just to simplify it. So ds bar will be equal to 1 divided by summation of x equals 1 to n into xi divided by dpi bar. So here if the number of the particles in each fraction is known, it is denoted by ni. Okay, for that we have one equation. See here, ds bar is equals to summation of I equals 1 to n into ni into dpi cube divided by summation of I equals 1 to n ni into dpi square. And the arithmetic mean, we are having this formula here, just see here. We are dividing it by ni and then we just divided it by nt. So nt will be the number of particles in the entire sample here. Okay. For our simplification purpose we have did here. Okay. To get the simple equation. When we divide this, we are getting dpi in the denominator. 1 dpi is left. Ni will be there. It is not cancelling. It is not cancelling. We are calculating here for the number of the particles itself. So it will be there. It will not cancel. Next it is mass mean diameter and volume mean diameter. So two equations are there. They are also similar equations. See, please note that all these equations look very similar, but you have to know that by the heading and what I have mentioned, which equation to be used on which particular type of problem, that you must be very consciously selecting for. That you have to see the formula, then you have to try to solve the problems. See here, dw bar is equals to summation of I equals 1 to n xi into dpi bar. So this is mass mean diameter. dv bar is also there, which is the total volume of the sample by the number of particles in the mixture, is an average value. Okay, see here it is given. Again it is a ratio equation. dv and dw. dw is mass mean, dv means volume mean diameter. So kindly check these equations very properly and very nicely. So I will see here what it is. See, for samples having the uniform particles, these averages are all same. See, samples who have the uniform sized particles or the diameter will be almost the same, no? So the average will also be same for all those samples. But the samples with the mixtures of various sized particles, the average diameters will be differing widely. So when there is no uniformity in the size of the particles, obviously the average value of these diameters will also vary. That will change. So lastly we are seeing number of particles in a mixture. So this is for the differential analysis. Here see, capital N is given, that is mass of the particle by rho P into Vp is used, okay, for the mixture of particles. Also for given particle shape, volume of any particle is proportional to its diameter. See here, volume of any particle will be proportional to its diameter cube here, and A is the volume shape factor. See here I have given. So total population in one mass unit of the sample is by the sum of all the fractions. So as I have told you, anything you have to calculate in total means you have to add the individual fractions, you have to add the sample fractions, then you will be getting the sum. Okay, so NW is given by 1 divided by A into rho P into summation of I equals 1 to N xi by dpi bar, this is cube. See here we are just simplifying this. Okay, just simplifying this, just easy. Okay, don't confuse with tens and thousands of equations. Just check it which will be useful for which kind of problems to be solved. Okay, so these are all simple equations. The simplified form equations I have given. Just go through it. Okay, I know they are very tough because many equations are there. It may confuse. Try to practice and check these all equations once again. Okay, thank you.